Hello everyone, welcome back to the 5 Minute Tech channel. Today we will be talking about how to generate the code for microservices through AI, and there will be a simple implementation on which there will be AI driven microservice code generation which will help us take an idea from running microservices in minutes. So let's get started on that. So microservice maze, it has challenges. It is lot of services. It has lot of boilerplate code. Service complexity and data consistency is required. Deployment overhead is there along with maintaining the standards across all the services. So this entire boilerplate code, complexities and dependencies add a lot of overhead which can be solved through AI generated code. So AI core, what we do is we pass a natural language prompt from whatever we want to develop. In our case, we'll be developing the services around the shopping cart. So we'll pass the prompt for creating those services, and we will see how it will unfold into a C# code with the prompts which we have provided. And we also will provide the intent and the context to the particular AI model, and that will generate the configurations and the boilerplates along with the code. So AI code generation patterns, it has auto completion and suggestions, real-time context aware and suggestions for lines, functions or blocks. You can even pinpoint a particular function in a file and ask for certain corrections and alignments. Example is a GitHub Copilot in Visual Studio or Visual Studio Code. Then prompt-based generation, you can prompt the AI or models to describe a specific code or logic in a natural language, and this generates the block of or the entire file for you. And we'll be showcasing that as well. The example will be prompting for a block or a controller. Refactoring and explanation, highlighting the potential improvement in the fixes or the bugs of the bugs, or explain the complex code scenario snippet. So if there is any complex code, you can just highlight that and ask for an explanation. And the example being AI is explaining a regex suggestions, a switch expression and something like that. Why it matters for microservices? Because it increases our productivity. There is a less boilerplate and more logic that we think about, and don't worry about the basic plugging work. Faster prototyping, the idea is there in minutes to be implemented, and that could be done through your AI model. The improved quality and consistency, because you are consistently implementing to the help of the AI to across all the services. And then it helps us in building more and better and faster services. Now GitHub Copilot is the one which we'll be using in Visual Studio Code. It is seamless VS Code integration it has, and also it is trained on billions of lines of code. It is already ready to write a lot of much better code in terms of integration and application. And it is context aware of the code suggestions. You can provide the particular context of the file as well as per your need, and it is one of the better AI pair programmers for us. Now the problem with the manual coding is it is slow, repetitive, and it has error prone. Whereas with the AI powered workflow, which we'll be seeing right now, it will be very fast, efficient and consistent across all the services for the microservice. Now beyond the Copilot, you can also implement your local LLMs, as we have talked in our channel about Olama being one of the locally hosted set of models. It interacts with a lot of models. What you can do is in your laptop you can have Visual Studio Code, and using Code GPT extension you can call a particular Olama model, example a DeepSeek coder model, and what it does, it increases your data privacy and security, and then it has an offline access. Without internet also you can ask questions and get relevant answers. You have the full control and customization, and along with it is cost free after you finish the setup. So this is the demo time where we will take an idea of our shopping cart application and create number of services around it. So let's get started. So we are now here in our Visual Studio Code and we are going to create a folder for our implementation, and the implementation would be around the shopping cart product service and the order service. So let's go ahead and create a folder and open it in the Visual Studio Code. So I've created a folder called code, and here I'm going to cd into it. So I'll open the terminal and do us and actually we are already there in the code folder. I'll go ahead and create the product service. So for that we will go ahead and run the .NET new command and create the product service. We'll go ahead and get into that folder, product service. Now we have the project in place which we can use, and this is a project created by the .NET command line. Now we'll go ahead and update the code to use the Copilot, and with the Copilot we will be trying to append the service and make it work. So we'll go to the chat, and here we will be adding the text, the prompt to make it use the agent and try to give us the code. So let's go ahead and add the prompt. So this is a prompt to use .NET 8 minimal APIs to create the product service. The service should have an in-memory list of product, and the product should have an int ID, name, the string, decimal price, and an int stock quantity. Also create an endpoint of products ID that returns a product by its ID, and if the product is not found, return not found. Pre-populate the list with a few sample products. So this is the prompt which we'll be sending to the Copilot. Let's see what happens. So the prompt has returned with the reply: your product service .NET minimum API is now implemented. The service uses the list of product. There is a get endpoint and returns the product, and it is asking us to keep or undo. We'll go ahead and do a keep, and as you see, this minimal API is ready, which is ready to give us a list of product. Now you can go ahead and tell it to make changes to run this on port 5001. You can just simply provide that make changes to run this on the port 5001, and goes ahead and adds the use URL on 5001. That way it will be running on port 5001. Now also I wanted to add Swagger, so we'll go ahead and mention to it add a Swagger UI for this project. It will go ahead and update the program.cs file to add the Swagger swashbuckle, and it will import that, and it will allow us to run the Swagger UI. So this is one problem which happens. It needs to navigate to the product service, so then only it will be able to do it, but this is something which we can do. So that is product service, and we need to run the .NET package. And as you see, it gets added. Now this is done, so we are set up for running this application. Now let's go ahead and run this application to check if everything is looking fine. So we shoot the command run this application, and when we do continue, the problem again is that it goes one folder back, the root folder, but we can go ahead and do a cd product service, and we can do a .NET run. So if I have opened the simple product service folder, it would have been fine. So there's some build for failure. The build has failed. Fix the builder and run again, and the top level must be named a declaration. So fix this. We can ask it to fix this issue. And we can do a run. So let me do one thing. Let me open the product service folder so that it can do a fix and check what's going on. So I'm just giving the I opened the product service folder, and I see this error again. So it is asking, can it fix it? I say yes, fix it. Go ahead and fix this problem for me. and then it is working on fixing the issue. And then it asked me whether I can use this, so I can say keep, and I'll do a continue on .NET build. And then there is some other issue, and it is asking me it can fix it or not. So I asked the Copilot to create a product class, as record of product was throwing some errors. So I asked it to create a entity product, and I'm now asking it to put the product section in a separate class. Let's see what it does. So it has moved the product into a separate class now, and you can see the product is in separate class. I'll say to continue the build again, and it succeeded. Now let's see if we can launch this application. Launch the service. Let's see if it launches the service, and we should tell it to keep it. So we should continue .NET Run, and this should launch our application on 5001. So let's go ahead and launch this. And as you see, our application is working fine. It is it's trying to give us the product. We'll just go ahead and execute this, and we should be getting a response back. So this is one of the services. We'll do a simple another service for order service, and see how they can communicate with each other. So here in the terminal, we'll just do a order service creation, and then we will go ahead and open that in our GitHub, the Visual Studio Code. So we'll just launch another Visual Studio Code, and in this one we will go ahead and open the order service. So open folder, and we will go to that folder. So we are in the folder where we have created the order service. Now we'll go ahead and provide it the prompt to make it work as a service. So we will go to the view, chat, and we will tell it the prompt. So the first prompt we will say is make this service run on port 5002. Let's see what it does. And it has updated the launch settings, so let's keep this. We don't want to run it right now. Now in terms of it to be communicating with other service, we need the IHTTP client factory. So we will give it a prompt to add IHTTP client factory to make HTTP calls work correctly, and it is going to add that in the program.cs. So I think this is where it has added it, and we will keep this one. We will also add it remove weather forecast specific code, because we don't need it, and that's something as a boiler code it comes. It should be able to remove all the weather forecasting specific code here, and we will go ahead and say to keep, and then we will go ahead and add the prompt to generate the rest of the code. So first we'll go ahead and ask it to create all the models, the product DTO, the finalize order, and the order item details, and we will go ahead and also ask it to create order item request classes. Now these classes will be required to communicate across the product service as well as for the internal workings of the order service. So it is going ahead and creating those records. We do not need records, we probably need classes, so we'll just prompt it. We'll first keep it, and we'll say that convert these to classes in separate files. Let's see what it does. It should be able to move them to a separate models folder and remove it from here. So as you see, it is creating a model folder and it is trying to move all these objects there. And as you see, it has done all the changes, and it is asking us if we can keep it, and here it is. So we have all the models moved and ready to use. So this is our prompt where we create a post. We are asking to get a post endpoint. It should accept list of order item request objects. For each item, it must call the product service running at 5001. And to get the product name and price, use HTTP client factory. If any product is not found, return a bad request, calculate the total price of the order, and create the finalize order object and return it with a 201 created status. For now, use in memory list of stored finalized orders. So this is the prompt we are going to give it, and let's see what happens. So it is working. It first read the program.cs. It's trying to make changes to that. So here is the change which it has implemented. It asked to keep it. I just accepted it, and it is going to use this code to connect to the application. Now to the product service. So let's go ahead and see if we can add some more code wherein we can get the finalized application. Wherein we are going to get the products list. So we'll go ahead and now run this to first check how it is working, and then we will see. So what first we'll do is build this application. And we can say is continue, and there are some error. So let's ask it to fix it. It is automatically prompting to keep it, and if we continue, it still runs into some issue. So let's see how it can fix it. So this has fixed the application code now, and we can go ahead and ask it to run it. Run the application. And we say continue. It is going ahead and running this application on port 5002. Remember, our application is already working on 5001, which is the product service, and now we will go ahead and run the order service. So there is a problem, we didn't add the Swagger UI, so let's first ask it to add the Swagger UI to it. So let's go ahead and ask it to stop the run. Okay, we can go ahead and do ourselves Control C, and then we will go ahead and add Swagger UI. So it should be able to add the Swagger UI to this application now, and it asks to keep it and continue and keep and continue. It will go ahead and build the application now, and the build is successful, and then it asks me automatically to run it again. I say yes, go ahead and run this, and now in our application we should be able to see the application launching, which we are not. So it is asking me to put a Swagger at the end, and yeah, so Swagger was missing at the end. That was the problem. We'll go ahead and now try this out, and here we will put the product ID 1 and the quantity 10, and we will execute this, and as you see, the product ID is coming from the other service and other details are coming. So that's how you are going to interact with multiple services, and within the span of 10 minutes we were able to create a solid background of 2 services which are talking with each other through us through the IHTTP client factory, and the setup is almost ready in 10 minutes to add some more code and build on top of this project. So that was pretty much about creating the microservices and the communication between them through the GitHub Copilot within minutes. Hope you like the video. If you like the video, press like and subscribe to the channel. Have a nice day.